Hello, and welcome to another Lawrence Academy screencast. Today we're going to be talking about graphing quadratics in vertex form. Now, up until this point, all we've been doing is sketching the graphs of quadratics. What we're going to do now is we're going to actually plot points to come up with more precise parabolas. To do this, we're essentially going to need to do 4 different things to come up with our graph. The first of which, and I guess these are in no particular order, is to find the vertex. Now, with all the exposure that we've had to quadratics, finding the vertex should be pretty easy for us right now, especially if it's given to us in vertex form. So vertex is going to be located at h comma k. The next thing that we're going to need to do is we're going to need to find either the y or the x-intercepts. So let's just start with the x-intercepts. And when finding the x-intercepts, it's important to realize that there doesn't always have to be an x-intercept. There can be 0, 1, or 2 x-intercepts depending on the problem. And to solve for the x-intercepts, we're just going to set y equal to 0 in our problem. So go into our quadratic equation, plug in 0 for y, and solve for x, and we'll get our x-intercepts. Moving on, the next order of business would be to find the y-intercepts. And I realize I said intercepts. With y, there will only ever be one intercept. Right? So there will always be one y-intercept when you're dealing with a quadratic equation. All right, exactly one. And to solve for this, it's going to be very similar to what we did before, except for this time it's going to be x is equal to 0. So go into your quadratic equation, plug in 0 for x, solve for y. There is your one y-intercept. Once we've done that, the last thing that we need to find is what's called the point symmetric to the y-intercept. And essentially what this point is it is a point with the same y output as the y-intercept. So it will have the same y value, but it will be on the opposite side of the vertex. And I think this will become more clear to you once we try to do a problem on our own. But that is the 4th step, as finding the point symmetric to the y-intercept. So there you have it. These 4 things are essentially going to be how we're going to solve for graphing these things. Essentially, we're going to have basically 4, 5, 6 points, and we're just going to play connect the dots depending on the problem. So let's try one on our own. So as you can see, the equation is up here. I wanted to give us some room to have so I could write this out. So it's up in the top right corner. I've listed the 4 things that we need to find: the vertex, x-intercept, y-intercept, and point symmetric to the y-intercept. And hopefully the point symmetric will become clearer once we have a chance to actually show it. So finding the vertex, as I mentioned before, should be pretty easy at this point. We're just going to go in here to h and k. So h I know is -3 and k is -1. So now that I've done that, I'm just going to go over here and plot my vertex. Right, x-intercepts. All right, so I know that for my x-intercept, I know I have to set y equal to 0, and essentially in this case the y, right, is the f of x. So 0 equals x plus 3 squared minus 1. Right, solve for x. Right, we get 1 equals x plus 3 squared. Oops. I'm going to take the square root of both sides, and I get plus or minus 1 equals x plus 3. Doing the math out, I am left with 2 solutions here. X equals -2 and x equals -4. So the two x-intercepts I have is negative 2, 0, and also negative 4, 0. All right, so now that I have those 2 points, I'm going to plug them in. And negative 4. All right, so notice I can already start to see a parabola forming here with those 3 points. Now I'm going to find the y-intercept, which, of course, as we remember from the last slide, there's only ever going to be one. There's always going to be one, and that is the absolute most that we're going to have. To do that, I'm just going to plug in 0 for x. So I have f of x, which I'm just going to rewrite as y here. 0 for x, so 0 plus 3 squared minus 1. All right, so 0 plus 3 squared is 3 squared is 9, minus 1 is 8. All right, so the y-intercept is at 8, or 0, 8. All right, and we're going to write that one in here. 0, 8 is all the way up here. Last is the point symmetric, and there's not a whole lot of math involved in this step, but it can be a little bit tricky to understand, well, what are we talking about by symmetric? So basically, if you haven't noticed, the parabola is a symmetrical shape, which essentially we can fold over on top of the vertex, and the points will fall on the same side. So here, this distance here is 3 from the vertex to the y-intercept. Right, so if that distance is 3, there's going to be a point on the other side symmetrical to where the y-intercept is, 3 units away on that side. And it's going to be located at the same y value. Right, so the point symmetric is going to be located at negative 6, 8. All right, so see how this distance is 3 and that distance is 3, and there we have the symmetrical parabola. And let's see if I can draw this. That's not so bad. All right, yeah. All right, so see how if I were to fold this piece over that way, right, over that dotted line right there, they would fall exactly on top of each other. So there you have it. I mean, we graphed this out, and we really essentially just played connect the dots. So here we have 5 points. You won't always have 5. If there are no x-intercepts or there's one x-intercept, we could have fewer. But essentially, you're always going to have the vertex, and you're going to have the y-intercept and point symmetric. So you're going to just essentially be playing connect the dots when you're graphing a parabola. All right, so this was a little lengthy. It does take a little bit more time, and it's a little bit more of a grind than just sketching out a parabola. But now that we've walked through one, I'm going to take the training wheels off and give you one to try on your own. So here's a problem for you guys to try. Do the best you can on your own, and as always, there's your smiley face and a best of luck to you guys.